Okay, we're going to be working on sinusoidal functions or sine waves. So we talked about this type of wave yesterday. We're going to go over a couple other rules that you guys are going to need to know for your quiz. So yesterday we actually talked about specifically what a peak and a trough were, which are the highest and lowest points. So I'm going to actually put some lines on this graph here, just so we can get an idea. So these points that hit 1 are all considered a peak. And all of the points at -1 are considered the trough, which are the highest and lowest points. Okay. Now, in these types of questions, they may ask you for the amplitude of something. Okay. The amplitude is how far away something moves from the equation of the axis. Okay. Equation of the axis can also be found using peak and trough. Let's focus on amplitude to start. So our amplitude of this function here, we're going to write into an equation. We have amplitude over here, so we'll bring the equation over.
So it'd be 0.
Quite. Amplitude is peak minus trough. The peak is the number 1. Okay?
Oh, yeah.
So our amplitude, peak is number 1. Subtract, the trough is -1 divided by 2. Okay? When we subtract this, that's like adding 1. Two negatives beside each other, it's like 1 plus 1. We get 2 over 2, which is equals to 1. Okay? So the amplitude is 1. And what they're saying is that's the distance from the middle of this equation. It takes 1 unit upwards and 1 unit downwards. That's what the amplitude is considered. So if a sine wave of this specific sine wave, and I do need to point this out. This is this function specifically, y equals sine x. Okay? That can change. It can be moved all over, but we're just focusing on the original one. The amplitude of the original one is just 1 from the equation of the axis. Now, with that being said, we have an equation to solve the equation of the axis. Say this was a wave that was covering a lot more space and not right around the middle, and we were having trouble figuring out where the middle of it was. We can take this equation here, which is very similar to the amplitude one. There's just one major difference. Anyone know what it is?
Add.
We add instead of subtract.
That will cancel each other out.
So yeah, in this case, exactly what will happen. The EOA, we'll call it. Equation of the axis, yep.
So
the peak is the number 1, and we're going to add -1 to it, divided by 2. In this case, we're ending up with 0 divided by 2, which is
x equals 0.
not x. Yeah, it wouldn't be x. If it was x equals 0, that'd be a vertical line. We need a horizontal line. So what variable would it be? Y is equal to 0. So that's the equation of the axis. And what that means is we can draw a straight line across. Can I use different colors here? Yeah, here we go. Our blue line here is the equation of the axis. Y equals 0. The amplitude refers to it, how far away the highest and lowest points are from the equation of the axis. So these two formulas are important because we're going to start to use different types of periodic functions, and you need to know how to find amplitude or the equation of the axis. This stuff down here we're going to get to in another day. The other thing I do want to talk about is the domain and range of this function. Anything else?
No.
All right, period. We talked about the period of this function yesterday, and just to clarify, you can find the period from any point. Okay? So what I'm going to do is I'm actually going to try to find a period from a different point from what we used yesterday. I'm going to start here at one of the peaks. Okay? We're at 270, and remember, a period is when we reach the same point in the exact same way. So in this case, we're going to have to follow out an entire period here. So we're going to highlight it in purple. So we go down, and then we come back up, and now we're at the same point, approaching it in the same way. Okay? Yesterday we started at the origin and got back to the origin. The trouble with that is we technically passed the equation of the axis twice, so it got a little confusing. This one here, what we've done, so I want you guys to recognize we are at the peak. And remember, before that peak, we were coming in an upwards fashion towards it. So we came down and we came back up again. So we know we're reaching it in the same manner. What's important now, though, is to figure out the distance between these 2 points here. Okay? So, it's very good. It's going to be that.
What's that called?
This is a period.
What is it going to be?
So, what we're going to do here is we have -270. And what we're going to do is we're going to subtract these numbers to figure out what the entire period of this periodic function is. So we'll do it on the side here. The period is equal to, we'll start with the highest number, 90, and we're going to subtract where we started. Subtract negative 270. Okay? What's that going to give us? 360. And remember, this is measured in degrees. 360 degrees. It's the exact same as when we started yesterday. Yesterday we had started at the origin, and we went up, down, and back to here. It was a lot easier to tell because we started at 0 and ended at 360, so we knew the period was 360. All periodic functions, no matter where you try to find the period, it will be the exact same. Once you find it, that period is consistent throughout the entire function, as long as it's repetitive. Okay, so the period is 360 in this case. That's how you find it. Start at a point, draw all the way down, and get to that point one more time.
How do you find the period if it's not repetitive?
It's not a periodic function. Okay. Yeah. Good. Okay, domain and range, the last two things we want to cover with this. So, our domain, this is a function that goes on forever. Technically, it does not stop. So, for my domain, what is my domain going to be if this is a function that does not stop?
X equal Y equal
XER. All right. X is the element of all real numbers. It goes on forever. Now, let's go back up again. Our range, it is a continuous function, so we're going to start with YER, but there is going to be restrictions to it.
Smaller than 1 or greater than negative.
Very good. It's going to be less than 1 and greater than negative 1. So, one way to represent that is we have negative 1, and we know that y is greater than negative 1, and it's also less than the number 1. That'll be the range of this sinusoidal function here. Okay. I think that's everything we got to cover for that. Here's another example of a periodic function. This one is a person's height above the bottom of a pool when they're floating, let's say. So we'll say this is measured in meters, our y-axis, measured in meters. And this will be time in seconds. So the person starts, we're going to say, at 2 meters above the bottom of the pool. And we get the idea that there's probably waves in this pool. So they're floating upwards and then coming back down, up and down. Their buoyancy is going up and down in the pool. Okay? So there's a couple things I want to ask you. First of all, is this a periodic function?
Yes.
Yes.
Why is it periodic?
Because
Okay, it's repetitive, and the peaks and the troughs all hit the exact same point. You could have something that's repetitive, for example, like this. This looks repetitive, but it constantly changes. This will not be periodic because the peaks and the trough are actually increasing and decreasing. Even though it looks like it's going up and down, it's not technically periodic. So we have a periodic function here. That's good. What would the peak be in this function?
2.4.
2.4. Good. The peak is 2.4. And what's the trough, the lowest point? Good. So we got those two things down. How long is a period in this function?
8. 6.
4.
How did you get 4?
Because when it starts at 2,
peak to peak,
because it has to go back to the same point along the x, right?
Okay, so they've gone up. We come back down. We're at 2 again. Is that a period?
No.
Why not?
No.
Because we were heading downwards where we probably would have been heading upwards at that point. So we come back down and up again.
That's a period.
That's 1 period, which is how long? 4 seconds. Good. So it takes the person 4 seconds to repeat the pattern that they're going through here.
Like drowning?
So here's a period. No, they're just floating on a pool.
From the top?
Yeah, you could start it.
You can start it from there.
We could have done the same thing. We could have started from here. Okay? Gone all the way down and up. And our 2 points would have been the number 5 and the number 9. Our color's not really good. Let's get another one. Let's say 5 and 9. And if we subtract the 2, 9 subtract 5 equals
4.
4. Exact same as we found before. Okay? Like I said, no matter what you look at, wherever you try to measure the period from, you'll come out to the same answer. Now, how long does it take for 2 cycles?
8 seconds.
8 seconds. We essentially just double the period, right? What about 3 cycles? What if it was 3 cycles?
6.
12. We're just multiplying it by the amount of cycles, right? Once we know the period is 4 seconds, we just multiply by the amount of cycles. All right, the amplitude of this. Or actually, because it usually makes more sense, where is the equation of the axis? Equation of the axis is what?
Oh, the y is 2 divided by 2.
Y is equal to 2, right? You can look at this graph and see it. Now, maybe I've given you this in words and I haven't given you the graph, so you might have to calculate it. And in order to calculate it, we take the peak, which is 2.4, and we're going to add the lowest point and divide by 2.
4.
Okay.
Peak is basically
1 divided by 2.
It's trough.
Trough is the lowest point.
So
Peak is the highest point.
So it's basically I mean not peak. Axis of
It's 2.
It's the middle.
yeah. It's basically axis of symmetry.
2.4 plus 1.6 is what?
4.
Divided by 2. Good. This is exactly what we found. What is the amplitude of this?
0.8.
That will be the range, which is something we didn't talk about. 0.4. That's how far from the equation of axis to the top and the bottom. So the range,
2.4 subtract 1.6.
the range is the peak minus the trough, and our range in this one would be 0.8. And then in order to find the amplitude, you take the range, or the equation we have before, amplitude, is equal to range divided by 2. Is another way to describe this. So 0.8 divided by 2 is 0.4, and that's the amplitude. That's how far up and down it goes from the equation of the axis. Now let's say this person gets out of the pool at 12 seconds. 12 seconds, they decide that I've had enough, and they get out of the pool. What is their domain and range going to be? The domain will be what?
That's X, right?
Yeah, well, it's continuous, so we definitely have XCR.
And
Any restrictions?
Yeah, he gets out.
He gets out. So when did they get in?
At 2.
They got in at what? When did we start measuring?
2.
0. So at 0 seconds, that's when we started measuring, right? Makes sense. You'd start measuring at 0. You wouldn't start at negative numbers or anything like that. So we know that our domain is greater than 0, and he gets out of the pool at what time? So what is the other part of the restriction? It's got to be less than
12.
So there's our domain and the range. YER, such that what?
1.6 is less than X.
X?
Y.
Y is
Greater than 2.4.
close. You
Less than
just said it backwards, that's all. Your numbers are right. Y is greater than 1.6 but less than 2.4. We got the period, we got domain, range, amplitude, equation of the axis. That's good.